In this lesson, we talk about brute force GI engine. Brute force is the most basic GI engine. It's straightforward, very easy to set up, and gives you the best GI solution out there. One problem though, it's very slow, and the reason being is in brute force, every shaded point, obviously in the camera view, has its GI computed separately and independently from other points. So even though it's slow, but because brute force calculates GI for each point separately, it can give you the most accurate GI solution. So let's jump in and see how it works. For the first part of this lesson, I'll be using the same scene we had for our previous lesson. Let me open up the frame buffer. Now let's see how brute force works in general. Our camera is roughly here in the scene. Brute force is a view-dependent GI method, so everything should start from the camera to determine what is in the view and what's not. So the first rays, let's say they are green, are cast from the camera. Now, because in this case brute force is handling our global illumination, every single shaded point or every pixel in the camera would get one of these rays. So if you imagine a 1000 by 1000 render, we are gonna have roughly about 1 million initial rays from the camera. Now at each point we are gonna have a GI sample, obviously. Let's say they are red. Now, from each sample, the first primary rays in a hemispherical fashion will cast into the scene and start gathering information from the scene. The number of these primary rays depends on the subdiv parameter in our brute force settings. Now, based on those information, we are going to have our GI solution for those points. So that's what brute force does if chosen as a primary engine. If selected as the secondary GI engine, from each point on the surface that was hit by a primary ray, a single ray will be traced and starts to bounce back and forth in the scene. The number of those bounces depends on the secondary bounces parameter in the brute force settings. Now let's see how brute force is going to handle our global illumination in this simple scene that we have. In the render settings window and in the GI tab, make sure to enable GI. As you can see, you can set brute force as your primary or secondary engine. In this case, let's set it as our primary engine, and for the time being, let's set the secondary engine to none. Now, without changing anything, let's render the scene. To analyze the renders a bit better, in the render elements tab, let's add our global illumination and our lighting passes. Now, as you can see, we start rendering the final image immediately when brute force is set as our GI engine. When we cover other GI engines, you realize that actually they go through some pre-passes to calculate GI before rendering the final image. Now let me stop the render and show you the final render. It took almost 7 minutes, even though we haven't changed anything and every setting is at its default stage. You can see it's a bit noisy, and if you compare it to the render from the previous lesson, you can see it's a bit darker, and that's because right now we are only using our primary engine and there is no secondary engine to handle our subsequent bounces. Now let's close the frame buffer and get back to the render settings. In the brute force GI rollout, you can see the subdivs parameter is grayed out. V-Ray is interrelated in almost everything, and right now we are letting our image sampler and global DMC controls, which we'll be discussing in the next section, to control almost every subdiv parameter in the scene. So basically, based on the settings in our image sampler, it decides how many samples it needs to calculate the GI solution. It's a very reliable system and almost always works. Here, because I want to actually demonstrate how this subdivs parameter works and affects your GI solution, I'm going to limit the image sampler power a bit by doing the followings. First, in the image sampler tab, set mean shading rate to 1 and turn off divide shading subdivs. In the bucket sampler rollout, enable use local subdivs. Let me set my noise threshold to 0.1, which is a ridiculously high number. Now, if I go back to the GI tab, you can see now not only the subdivs parameter is available in the brute force rollout, but now if we actually change this parameter, we can see how it works. So we said that the subdivs parameter determines the amount of primary rays, but the actual number of the rays is proportionate to the square of this number. So right now we have 8, so we expect to have about 8 by 8, 64 samples or rays. But as you can see, the number reads 16. That's because we still have some adaptivity controls that won't allow us to use all of these 64. And that particular control is adaptive amount in the global DMC rollout. If I go there and zero it out, now you can see the number actually reads 64, but it's not wise to do that. And let me set it back to 0.85 and get back to our GI tab. We'll be discussing these parameters. I mean, I'm trying to not confuse you right now. I know these parameters are really confusing right now, but at the same time, I need to touch them here and there to make sure when we actually talk about image sampling in our next section, you know how it relates to, for example, GI somehow. Now, to avoid any confusion, let me just focus on the GI tab and imagine there is no image sampler at all. So let me set the subdivs to 1 and see what would the results be in our frame buffer. As you can see, the render was very quick, about 54 seconds. Not very quick, but hey. The render is extremely noisy. As you can see, we have so many red, green, and dark pixels. And the reason is each GI sample, remember those green rays coming from the camera and making the GI samples, the red GI samples? And from those samples, we cast the primary rays, right? Those rays would go out in the scene to gather information and determine the illumination of that point of that sample, right? Now the subdiv or the subdivs parameter is set to 1. In the best case scenario, each sample only casts 1 ray, right? And that ray can only hit one surface. So for example, in that case of this red pixel, for example, that one ray had encountered the red wall, and because it couldn't send any more rays to gather more information from the other surfaces and average the result, we get a red pixel, right? So you can see the overall result is really noisy and unacceptable. And if I go to the global illumination path, you can see it's quite, clear how worse it is. And the illumination also, it's not only noisy, the illumination is not going to be correct because we just don't have enough rays to go out in the scene and make that sample look correct. So the overall result, when we average all the samples together, would be a mess. Now let's get back to our render settings and set the subdivs to 2 and take a look at the result. As you can see, the result is a bit cleaner because now each point or sample can send out up to 4 rays into the scene. So 2 by 2, 4. So obviously it's a bit better, but not quite perfect. We can compare these to our previous results, and also we can take a look at the GI passes and compare them and see how cleaner it gets, which is not too much. Now let's set the subdivs to 8 and take a look at the results. As you can see, it's a lot cleaner compared to our previous results. And if I compare the GI passes, you can see we get a much better result. Now in the next render, brute force subdivs is 16, and no surprise, the result is better and less noisy. In the next render, I cranked up the subdivs number to 64, and now the result is really better. But as you can see, the render time went from 53 seconds in our previous render to 8 minutes and 30 seconds, right? And if the scene was more complex, even 64 wouldn't do anything for us, and we needed to increase that number to 128 to 156 until we get that beautiful noise-free result. Now, if I go to my lighting pass, you can see some of the noise in the scene is coming from the light source that we have in the scene, so from the direct lighting. To make sure the light is giving us a clean pass, let's select the light and increase its subdivisions to 128. Now, as you can see, we cleaned up the overall noise produced by the light. And we need the secondary engine to come in and start bouncing our primary rays to get more accurate GI solution. In our render setting, let's go to our secondary engine and let's select light cache. I mean, you wouldn't normally use brute force as your secondary engine, and light cache can be very quick as secondary engine and produce excellent results. So let's see, make sure brute force subdiv is 64 and light cache subdiv, maybe something like 1000 would work in such a simple scene. And we'll be discussing light cache obviously in a future lesson. If we take a look at the results, now that we have a secondary engine, the render is a lot brighter and more accurate compared to our previous render. And especially if I compare the GI passes, you can see how it differs from the previous renders. And because we obviously have the secondary engine and the whole illumination gets a bit brighter, that helps us to kind of hide some of the noises also. And finally, to get rid of those aliased edges that we have, we need to increase the quality of our image sampling. Decrease the noise threshold to 0.007, and as I mentioned, it's really interrelated, and I need to kind of touch some of these parameters sometimes here and there to get the result that I want. So, and if I take a look at the render with these settings, you can see the render took up almost 45 minutes, but the render is pretty clean, right? Perfect. Now what we can is to give V-Ray some of the controls back and see how it works. So in our render settings, let's enable divide shading subdivs and increase the min shading rate to 256. I mean, 256 is a high number, and you wouldn't use possibly such a high number here. But because this scene is raw and I don't have any material, and these rays are going to be primarily used for kind of GI, to increase the quality of GI, that's why I'm using. So if you know V-Ray and you know your way around V-Ray, don't accuse me of ignorance or anything for increasing this number that high. Right now I'm just having GI, no other effects, no materials, so these extra rays are going to be used with GI. And so for now, and we'll be discussing image sampling in detail in our next section, but for now let's turn off use local subdivs and render again. The render you would get is not as clean as the previous render, but it's quite clean and acceptable, and it took only 12 minutes, which is almost 4 times faster compared to our previous render. Also, if we kind of added the denoiser that we have used in our previous section also, and we used the preset like mild on that, we could have kind of have a very clean render without that extra time. Maybe it would have been a bit softer, the overall result, and we wouldn't get as much as detail, but still it would have been amazing. Now let's explore a bit more complex situation. Now in the next scene we are dealing with a very detailed interior scene. As you can see, I have a V-Ray sun and sky in the scene, and also 2 skylight portals that help with the lighting as we discussed in our previous section. The curtains have been excluded from these portal lights. Except for the curtains, all the objects in the scene have a neutral gray material applied to. And the curtains have a translucent material which allows the sunlight to enter the room. In the render settings window and under the GI tab, make sure brute force is your primary engine. Like the previous example, let's set the secondary engine to none. Our image sampler parameters are at their defaults. Also in the render elements, we have lighting and global illumination passes. Let's render the scene and see what we get. As you can see, it almost took 40 minutes to render this. The GI solution is quite accurate and we keep every detail in the render. But if I go to the GI pass, you can see it's really noisy in some areas. Now let's go back to our render settings and make sure min shading rate is 1 and divide shading subdivs is disabled. Increase the noise threshold to 0.1 and enable use local subdivs. And let's render the scene with the subdivs set to 1, 8, 16, 64 and 128, and let's see what we get. And to make it easier and quicker, I just render half of the image because it's really gonna take a very huge amount of time to render the scene when we're actually using a high subdiv number. So in the first render, brute force subdiv is set to 1, and as you can see, the final render is very noisy and the global illumination pass is not presentable at all, and it's very inaccurate because we don't have enough rays and enough basically enough rays to gather information for the samples in the scene, right? As we increase the subdiv to 8, we start to get more accurate GI solution, right? But it's still very noisy and dark. Make sure to check both the RGB and the GI passes here. Now, when set to 16, we don't have any noticeable improvements. It's generally a bit better, but really it's not that much better. When set to 64, now we get something significantly better and the render time has almost doubled compared to the previous render. Now, this render is quite cleaner, but it's still noisy. When we set this to 128, we get much cleaner render, but as you can see, it's still quite noisy, even though it took almost 20 minutes to render. Now, I can go ahead and increase this to 256, but it's still gonna be some noise in there, and it's gonna take a very long time to render. Instead of increasing these subdivs again, let's enable our secondary engine and use light cache as the secondary engine. But honest to God, when you're actually trying to render an interior scene with brute force, which is not a good idea to actually render interior scenes with brute force, and I'm gonna get to that in a moment, but you really need to crank these numbers so high to get that noise out there. And it's just gonna take a very long time unless you have a very powerful network of machines to render your scenes. You're gonna be in a very bad situation. Now in the light cache settings, set the light cache subdivs to 1500, and to reduce the overall noise, let's decrease our noise threshold to something like 0.01, so our image sampler can get rid of some of the noise produced by our GI and also some of the LES edges. Also, let's add a V-Ray denoiser pass and set the preset to mild, so we can also have a clean pass generated by our denoiser pass. Now, if you take a look at the results, as you can see, the render is quite clean and acceptable. The GI solution is extremely accurate and keeps all the little details in the scene. But the render time, even though I just render half of the image, is more than 2 hours on this machine. Even though when I render, I almost do all the other things in the background, you know, editing the videos and browsing web and all of that stuff. But even with that, it just it takes too much. Also, if I take a look at the denoiser pass, you can see it's giving us a super clean pass, which is amazing. As it appears here, it's not a good idea to use brute force in a complex interior scene because it's very, very slow. I even didn't dare to render the entire scene because I knew it would take a very, very long time to finish. To wrap up this lesson, let's summarize the strengths and weaknesses of brute force GI method. For its strengths, we can say that it preserves all the details. You can see there wouldn't be any artifacts or flickering in the animation if you use brute force as your GI solution when you are rendering an animation. it doesn't require tons of RAM, so if you don't have enough RAM on your machine, you can simply and safely use brute force to handle your GI. And as its weaknesses, we can say it's very slow, unfortunately, and especially for interior scene. It's really hard to clean it up, and there would be noise to some extent in the final render, even if you use a high amount of subdivision, which is not a good thing. Perfect. So that's about brute force, and in the next lesson we'll be discussing Irradiance map.